All right, so we've discussed translational motion, but as we previously mentioned, when we have a body that is rotating essentially around an axis, we'll also be dealing with basically bodies that are undergoing translational and rotational motion. So this happens quite often. You can think of shafts and rotation and tire wheels, lots of examples. We'll be going over some fun ones, but rotational motion is critical to analyze. And what we're going to be looking at is we're going to be looking at basically tracking the angular displacement, which can be defined as such. So we're going to be looking at the change in those angles theta as it rotates around some fixed axis. We can also define angular velocity, which will be just defined as so. And then finally, angular acceleration, which is just the second derivative. So you see kind of this very similar framework for translational motion where we're looking at the displacement in meters versus angular velocity, which is going to be rads per second, and then radians per second squared. So we can look at those values, or you can put it in degrees as well. But basically, we're looking at those units that we're going to be working with here. Fantastic. You'll also you can actually basically encounter some that are normal or tangential components of angular rotation, and those can just be defined here. But predominantly, again, we're going to be dealing with that. The key other equation that we have that's going to govern our rotational moment is that the sum of our basically moments around basically our center of mass, g of our body, will be equal to the moment of inertia, I, times our angular acceleration, which we just defined previously. So when we're looking at rotation, it's not going to be F equals ma like we saw here. Instead, the sum of our moments will be equal to this. So our moments about in the center of mass will be equal to this, or generally around some point P, it'll be equal to, again, essentially sum of all those moments. But this is kind of the key thing. So if our body's undergoing rotation, our sum of our moments at the center of mass of our body, G, will be equal to IgA. So Ig alpha, excuse me. So that is really, really critical here. Now, calculating that Ig, basically the moment of inertia, that's going to be left for other classes. So we're going to probably just give you that, for our purposes here. So for translation and rotation, these are all of our fundamental equations. Or again, we can use this previous, we can basically substitute or basically use this definition or this definition. So some problems, it'll be easier to use one versus the other, and it'll be helpful when we actually go and start doing that. So next video, we're going to talk about the distinction between our problem-solving algorithm from statics. It's pretty straightforward. It's just one more additional diagram, and then we'll start to solve some problems. So see you then. Thanks. Bye.